Hello, my name is Allie, and we're going to be interviewing random high school students. Hello, we're here to interview random high school students. What is your name, your grade?
Sean Yi, and I'm a 12th grader.
Do you think math is red?
I think math is red, yes.
No.
Yes.
No.
Yes.
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 No.
Yes.
No. Yeah.
Alright folks, there you have it. Math is red. With 7 people saying yes and 4 people saying no, that's 63% of people saying yes. Obviously, it makes math red, right? Wait. Alright, so our data with only 11 people showing 7 yes and 4 no is not enough because it doesn't satisfy the normal distribution. So using my quick calculations, 11 times whatever, it shows that it does not satisfy the normal distribution, meaning we have to get more data and more people. So me, Allie, and Ethan came up with a plan in order to collect as much unbiased data as possible in an efficient manner. And so we went to different classes with a newfound knowledge to collect more data on is math red.
So in order to collect unbiased data in the most efficient way, we came up with a system of printing out slips of paper and then handing them out. So on the slips of paper, we included a portion where you can fill out your own name, circle your grade level, and then whether or not you think math is red. So our process was first creating the slips of paper on a Google Doc where you could see like the table and us creating the individual squares, and then we cut them out. Then we went to different classrooms.
Hey, excuse me. Do you have time to fill out a quick survey? We're trying to collect data to see if people think math is red. So just write down your name, your grade, and whether or not you think math is red.
So now, after collecting all the data, we type all the names down onto this school sheet, type the grade, and we type their response, the answer, so yes or no, and then we have the total amount there, we have the amount of yes, amount of no, and the probability of each. And now it's time to analyze the data.
Now that we have our data, we can analyze it. Our null hypothesis is from the website at the beginning, saying that 54.2% of high school students will think math is blue. Our alternate hypothesis is that a majority of high school students will think that math is red instead. Compiling our data into graphs, we can see that the proportion of students who think math is red is around 61.8%, which gives us a p-value of 0.6179. To assume our data is a normal distribution, we must fulfill 3 conditions. The first is that our samples are randomly chosen, and the second and third are that n times p and n times q, or n times 1 minus p, are greater or equal to 10. For the first condition, we randomly chose classes with a wide range of grades. For the second and third conditions, 123 times 0.6179 and 123 times 0.3821 equals 76 and 46 respectively, which are both greater than 10, satisfying all the conditions to assume we have a normal distribution. Now that we know our data has a normal distribution, we can construct a 95% confidence interval, which we know will have a z-score of 1.96. We can use the equation p hat equals z times the square root of p times 1 minus p over n, which plugged in with our data will give us 1.96 times the square root of 0.6179 times 1 minus 0.6179 over 123, which will give us 0.002. Multiplying that by our z-score will give us our margin of error, 0.00392. Adding and subtracting our margin of error from our p will give us our confidence interval of 0.614 to 0.622. Possible bias in our data is that it did not have that many 9th graders. This is undercoverage bias. We also did not pull any English or math classes, instead only pulling a science class and 2 CTE classes. This is also undercoverage bias. People who do not correlate math with any color may have also lied and said yes, resulting in response bias. Because we were only able to survey classes who we got permission from, we were only able to survey these 3 classes, resulting in some of the biases here. In conclusion, based on our data, our alternate hypothesis is correct, and we are 95% confident that at the lowest, the true proportion of students who think math is red is 61.4%.